And here's the one with the explanations. So, in general, what I'd suggest is if you're having difficulty with a certain problem, fast forward to that. There are a lot of proofs on here, so this is going to end up being a bit longer than the other review ones. So just find out the problem that you're having an issue with and go from there. So let's start with number 1. So on these first 3, keep in mind that what we're doing, I want you to start off by kind of ignoring the diagram. And when we look at that congruency statement, IKJ is congruent to IQR, there are really, really there are those 6 statements in there, because remember, what it means for 2 triangles to be congruent is that their corresponding parts are congruent. Well, a triangle has 6 parts, 3 angles, 3 sides. So we can write down those 6 congruent statements. Now, all of those we can write down just from looking at triangle IKJ is congruent to IQR. Angles match up, sides match up. So then, when we sit there and we look at the diagram, it's just a matter of marking down. I is congruent to I. K to Q. J to R. And then the sides. IQ to IK, KJ to QR, and IJ to IR. Okay, and that's it. So then we go and we repeat the process with number 2. We mark down our 3 angles, write out our 3 sides, and then we go P and C are congruent, Q and A are congruent, R and R are congruent. Now again, that we get that simply because of this statement right here. Okay? So it's not magic. You just match up first with first, second with second, third with third, and then the sides are 2 at a time. So the sides, PQ, CA, QR, AR, PR, CR, and you're done. Now, if you're feeling good about it, and you can just kind of go straight from those. So we can go match up the first to the first, V and D. If you need to, though, write out those 6 statements. Don't even look at the diagram. Write out those 6 statements, and then use the statements to fill in the diagram. So V and D, those are the first ones, so they match up. U and T, those are the second ones, they match up. T and B, those are thirds. So sides we take 2 at a time. VU, DT. Those are the first 2. Then we take the last 2. UT, TB. And then we take the first and the last. VT, DB. And that way, we're done. So those are those 6. So write a statement that indicates that the triangles in each pair are congruent. So for 4, 5, and 6, all of these are congruent. And we know that a triangle congruency statement is going to look something like that. Triangle, 3 letters, is congruent to triangle, a different 3 letters, or at least a different setup. So here what we're going to do is we're going to look at those how the angles match up. So we're going to look at the bottom triangle. We get U, that's got 1 arc, and that is congruent to the triangle with 1 arc in the top triangle, so U and T. Do the same thing with the 2 arcs. U on the top, T on the bottom. TU. 3 marks, S and V. So there we go. UTS is congruent to TUV. Repeat that process for 5 and 6. We're going to look at the angles with 1 arc, F and U. Angles with 2 arcs, G and T. Angles with 3 arcs, H and H. So we get FGH is congruent to UTH. Repeat the process for number 6. 1 and 1, Q and Q. 2 and 2, P and P. 3 and 3, R and C. QPR is congruent to QPR is congruent to QPC. State if the two triangles are congruent. If they are, state how you know. So with all of these, they give you two pieces of information, either an angle on the side or two angles or whatever. Then you need to kind of look at it and see whether or not you can put the rest of it together. So for 7, we see that we're given two sides, and we know these are bow tie angles, or vertical angles is the actual term for them, and they're congruent. So we can say that those two triangles are congruent by SAS. Number 8, we have an angle and a side, and again, we have vertical angles. So that's going to give us a second set of angles. Now notice that we're going to say AAS here, not ASA, and the reason is the side isn't in between the two angles. See how in the actual lettering it goes angle, angle, side? If we had this side right here, the one I just marked, that'd be angle, side, angle. You see how the side is in between the two angles? Here, the side is not in between the two angles. It is a non-included side. Therefore, we say angle, angle, side. 9, we have two sides and an angle. And the problem with that is that there is no, the angle isn't included. So we have SSA, side, side, angle. Well, there is no SSA or ASS in geometry. So we say no. Those two are not congruent. 10, we have those two sides, an angle, and then, hey, look, we have that middle one down the side. If we were doing a proof, we would say it's congruent to itself by the reflexive property. But if we were to draw those two, triangles separately, we'd see that those bottom sides are congruent. So we're going to say yes by SAS. Same general idea for number 11. You've got that middle side. I love that term, the side in the middle. You've got the middle side being congruent to itself. So we're going to go side, 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 because we have three sides on one triangle congruent to three sides of another triangle. Say what additional information is required in order to know that the triangles are congruent for the reasons given. This is 12 through, I think, 15. So here we have AAS. That's angle, angle, side. So keep in mind, that's two angles and the non-included side. So those are our two angles. That's our side, WX. So we're missing another angle. Well, we want to make sure that we can't have YWX and TXYW be congruent, because that would be angle, side, angle, because this side would be in the middle. So instead, we're going to say Y and T are congruent. If we were given that information, then we'd be able to prove angle, angle, side. 13, we're looking at hypotenuse leg. So hypotenuse leg requires three things: right triangle, congruent hypotenuse, and congruent leg. So we're given that the right triangle, see we've got that little right angle signal down there. And then we have that CB is going to be congruent to itself. Well, is that a hypotenuse or a leg? It's a leg. So we need to show that the two hypotenuses are congruent to each other. So we're going to say that what we're missing is CD is congruent to CR. Here on 14, we have one side congruent to each other, two sides congruent to each other. So in order to prove side, 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 we are missing the third side. EF is congruent to IF. (15) Side, angle, side. So we've got DM is congruent to NM. We've got our vertical angles right there, LMN and BMD. So in order to prove side, angle, side, we're missing that second side that would turn it into a, and now keep in mind, what we're talking about is the included side, or the included angle. So it needs to be the other side making up that angle. So BM and LM. Side angle side. SU is congruent to TS. Angle TSR is congruent to angle USW. Again, the vertical angle theorem, all vertical angles are congruent. So we're looking for that other side. Again, it needs to be the side that creates that angle. The angle needs to be the included angle. So we're going to say WS is congruent to SR. So 17. So 17 through 21 we have one triangle, and then 22 through 26 we have two triangles. So in all of these, what we have to do is find the measure of angle 2, plug that measure back into the equation, and then go from there. Okay? So we go angle 2, right there. So here, we know that those two angles, by the isosceles triangle theorem, remember the isosceles triangle theorem, if two sides are congruent, then the opposite angles are congruent. So we know that 48 plus 2 times the measure of angle 2 equals 180. That's the angle sum theorem. So we're going to subtract 48 from both sides, and we get 2 times the measure of angle 2 equals 132. We're going to divide both sides by 2, and we get the measure of angle 2 equals 66. We then take that 66, plug it in up top, and we get 66 equals 11x. Divide both sides by 11, and we get 6 equals x. 18. Again, here we have an isosceles triangle, which means that those two base angles are congruent. Since one is 65, they're both 65. So plug 65 in up top. 65 equals negative 1 plus 11x. We're going to add 1 to both sides. And we get 66 equals 11x. Is he okay? We're going to divide 11 both sides, and we get x equals 6, just like 17. What a quinky dink. Okay, 19. So 19, we look at that triangle, and we go, hey, that's an isosceles triangle. How do I know it's isosceles? Because it's marked isosceles. All three are the same. We're then going to sit there and go, not isosceles, equilateral, equal sides. Equilateral means equiangular. That means all three are 60 degrees. So let's look how we figure out number 2. Well, it is supplementary with that 60-degree angle, which means it is 120 degrees. We get that by going 180 minus 60. So we go 120 equals 11x minus 12. We're going to add 12 to both sides. That gives us 132 equals 11x. We divide both sides by 11, and we get 12 equals x. Is there any coffee left? Okay, do you mind making another half pot? Thanks. So here, 20. We're going to kind of go backwards on that. Before we found the inner angle and went to the outer one. Here we find the outer, that exterior angle, and we go inside. Again, we know that they both equal 180. So 150 plus what equals 180? It's 30. Here we have an isosceles triangle, so we know those two base angles are the same. So 30 plus 2 times the measure of angle 2 equals 180. Subtract 30, and we get 2 times the measure of angle 2 equals 150. Divide both sides by 2, and we get the measure of angle 2 equals 75. Plug that into the equation we're given. 75 equals x plus 82. Subtract 82 from both sides, and we get x equals negative 7. On to 21. So here, we know that that base angle is going to be 55, which means the other one is also 55. We need to figure out that vertex angle, so we know that the vertex angle plus 2 times the base angle equals 180. So we get 110 plus the measure of angle 2 equals 180. Subtract 110 from both sides and we get the measure of angle 2 equals 70. So we plug that in. 70 equals 6x minus 2. We're going to add 2 to both sides and we get 70 equals 6x. Divide both sides by 6 and we get x equals 12. On to number 22. Okay, so 22, this is where it gets tough because now we've got two triangles. So what we're going to do is we're just going to ignore that bottom triangle first. So we start with that 107, and we know that its supplement has got to be 73 because they're a linear pair. If one of the base angles is 73, both of the base angles are 73. We know that the two angles plus the vertex angle have to equal 180. That's a triangle angle sum theorem. So that means that 73 times 2 is 146. 180 minus 146 equals 34 degrees. That's 34. So now we're going to look at that corner. So notice there's that right angle there. That means that those two angles together are complementary. They add up to 90 degrees. So if that top one is 34, that bottom one is going to be 90 minus 34, or 56. Okay, so now we're going to switch what we're looking at. So we've got that vertex angle of 56. We know that the measure of angle 2 is one of the base angles, which means both base angles are going to equal that. So we go 56 plus 2 times the measure of angle 2 equals 180. Solve through again, just like we have in the past. We get the measure of angle 2 equals 62. Plug that in, and we get x equals negative 10. Moving on. If any of these you don't understand, rewind it, watch it again. So here, we're going to start off with that 104. We know that interior angle is 76. Because the other one is 76 as well, those two 76s add up to 152. Which means that vertex angle is 28. That's 180 minus 28. 28 and the angle right below it are complementary, so we go 90 minus 28. And we get 62 degrees. Now look at where angle 2 is. It's on the outside there. So 62 and angle 2 are supplementary. So to find the measure of angle 2, we're going to go 180 minus 62, or 118. Then plug it in. 118 equals x plus 25. 125, subtract 125 from both sides, and we get x equals negative 7. 24. We're going to find the vertex angle there by going 180 minus 134. And that gives us 46. So we know that those two angles together are 90, so that's going to be 90 minus 46, or 44. That gives us two base angles of 44. Now here, I'm going to take a little bit of a shortcut. I know what I'm going to do is I'm going to use the exterior angle theorem. The triangle exterior angle theorem says that the exterior angle is equal to the sum of the remote interior angles. We just went through this in the previous lesson. So those two add up to 88, which means that the measure of angle 2 is 88. Plug in 88 for both, and we get the measure of angle 2 equals 88 minus 97, or negative 9. 25. Now here we've got the measure of angle 2 being a vertical angle with one of our other angles, okay? So, we start off with that 70. We know the other base is 70. 70 and 70 is 140. 180 minus 140 gives us 40 degrees. 90 minus 40 gives us 50 degrees. And because vertical angles are congruent, those base angles are congruent. So we have 50 plus 2 times the measure of angle 2 equals 180. Solve through, and we get the measure of angle 2 equals 65. Plug 65 back in. 65 equals 71 plus x. We're going to subtract 71 from both sides, and we get x equals negative 6. So, the last of the computations before we get on to proofs. Okay, so if that base is 69, the other base is 69. 69 plus 69 equals... So I'm explaining the remote interior angle. Anyway, 69, 69, 138. That gives me 42 up top. That's 180 minus 138. 42 plus 48 is 90, so the other complementary angle is 48. Because we know one of the base angles is 48, the other base angle is 48. And again, we're going to use the triangle angle sum theorem, not the triangle angle sum theorem, the exterior angle theorem that says the exterior angle of a triangle is equal to the sum of the remote interior angles. Again, that's something we did last chapter. So we go 48 plus 48 equals 96. So the measure of angle 2 equals 96 degrees. Okay, not the boy band. That's 98 degrees. So 96 degrees would be what? Just 96 degrees. Anyway. Okay, moving on. 96 equals x plus 106. Subtract 106 from both sides, and we get x equals negative 10. So that's all the computation. So now we have the proofs. So this is what I'm going to do. On the proofs, I'm going to generally explain what I did. And then, so I'm just going to kind of jump to the end of each proof. So here, what we did first was we proved, okay. So we were given that px is congruent to py and that zp bisects xy. What does bisect mean? Bisect means it cuts it in half. So therefore, xm and ym are congruent. So we know that pm is congruent to itself. So we were able to prove that triangle pxm and triangle pym are congruent by side, side, side. Because we're given two sides, we can figure out the third one. Sorry, I forgot to put that in there. Side, side, side. We then use the fact that corresponding parts of congruent triangles are congruent, or Cpctc, to say that angle xpm and angle ypm are congruent. We then say that pz is congruent to itself, and that's going to give us side angle side congruency, because we know that py and px are congruent. That was already one of the givens. So this one's a little bit trickier. Actually, it just looks trickier. So I know that 1 and 2 are congruent. I know that 3 and 4 are congruent. So that means that if I add 1 and 3, I'm going to get the same thing as 2 and 4. Okay? So I know that those big angles at the bottom are, so that's where I put DPA and CPB are congruent, because that's the definition of congruent angles. We were able to figure out that they're equal to each other using the angle addition postulate. Okay? We then know that AP and PB are congruent. That's just the definition of a midpoint. Remember, whenever you see midpoint or bisect or something like that, what a midpoint does, what a bisector does, is it cuts something into two separate congruent pieces. So whenever you see midpoint, you're going to want to set the two segments to each other and say just the definition of a midpoint. And that's going to give us the triangles we're looking for by side, angle, side. Because again, we got one of the sides, PB is congruent to PA. That's the definition of a midpoint. And then the other one, PD, is congruent to PC. Those are these inside V-looking ones. Those are given we were then able to use the angles that we were given in order to prove that the included angle between those two sides is congruent, which means we have side angle side congruency. Okay, for number what just happened? I think I skipped 19 and 20. That's okay. So 21, if you really have a question about 19 and 20, hit me up on email or ask me before the test tomorrow. But nothing on the test is going to look like those two. So I'll really quickly explain 19 and 20. 19, we have 1 and 2 are congruent to each other, and 3 and 4 are congruent to each other. We also know that AP and DP are congruent. So we're trying to say that those two... So what we're going to do is we're going to use 1 and 2 to be congruent in order to say that BP and CP are congruent. That's going to give us those two sides as being congruent. We also know that then, let me erase this really quickly. These angles right here and these angles right here have to be congruent. That's the congruent supplements theorem. Because 1 and 2 are equal, that means that PBA and PCD are congruent. Since we know that 3 and 4 are congruent, that gives us angle side congruency. Over on number 20, we got a couple parallel lines here. So whenever we see parallel lines in a proof, we want to immediately start thinking about alternate interior angles, same side interior angles, all that good stuff. So we have MP and SN as, and NS is parallel, and then RS and PQ as parallel. We also know that MR is congruent to NQ. So we need to prove that MQP and NRS are congruent. And the way that we're going to do that is we're going to say, first and foremost, that 1 and 4 are congruent. Angles 1, angle 4 are congruent. Okay? And that is because we've got MP and SN, and then the transversal would be MN. So those are going to be same or alternate interior angles. Under the alternate interior angle theorem, alternate interior angles under these circumstances are congruent. Okay, we then have angle 2 and angle 3. Now again, we know that SR and PQ are congruent. So MN is again going to be that transversal. So again, we're going to have alternate interior angles. Because keep in mind, we got these two, and so we say that those two are congruent. So we've got two angles. So we know that right here is congruent, and right here is congruent. Now, RQ is going to be congruent to RQ. So we can say that MR plus RQ equals NQ plus QR. And that's just the segment addition postulate. And then because of that, we can say that MQ is congruent to NR. Therefore, we have side angle, or angle side angle congruency. And that's how we do that. So, next up, 21. So again, we're given LO is congruent to MN, and LO is parallel to MN. Because they're parallel, we know that OLN is congruent to MNL. That's the alternate interior angles theorem. We know that then the triangles are congruent because LN is congruent to LN by the reflexive property of congruence. So those two triangles are going to be congruent by side angle side. Because those two triangles are congruent, we can affirmatively state that MLN and ONL are congruent by the fact that corresponding parts of congruent triangles are congruent. 22. This is a pretty simple one. We know that OS is congruent to OS by the reflexive property. We're given two other angles, so that's going to give us the two triangles together as angle, angle, side. Remember, it's two angles and a non-included husband. I don't know where the word husband just came from, but anyway. So we have reflexive property congruence. OES is congruent to STO by angle, angle, side. That's going to give us TO is congruent to ES because congruent parts or corresponding parts of congruent triangles are congruent. Flipping back to a two-step here, or two-column. So we're given that 1 is congruent to 2 and 3 is congruent to 4. We know that SQ is congruent to SQ by the reflexive property. So that's going to give us that PSQ is congruent to RSQ. And those two triangles are going to be congruent by angle, angle, side. So we know also that MS is congruent to MS, which we don't really need. We need, not MS, MQ is congruent to MQ. I don't know why I put MS. I mean, not that I'm wrong, it's just that doesn't really help our cause. So MQ is congruent to MQ. That's a reflexive property of congruence. We also know that PM and RM are congruent by the definition of a midpoint. We know that PQ is congruent to RQ because when we proved that those two triangles were congruent, PQ and RQ were corresponding parts. Corresponding parts of congruent triangles are congruent. Therefore, we have three sides congruent to each other, which gives us PMQ is congruent to RMQ by side, side, side. It's got two more to go. 24. Again, if you need kind of a slower walkthrough of these, feel free to just send me an email or comment. Please go through number 24 slower. And then I'll post a separate video on that, really walking through the individual ones. But it's getting late. It's, pushing 11:11. And if anyone's out there waiting, I want to make sure that you guys have the opportunity to look through these and work on them prior to tomorrow's test. So we're given that PO and OQ are congruent. By the definition of congruent segments, we're actually given that PO equals OQ. We then have to take that extra step to say that PO and OQ are congruent. We're given that we know that POA and BOA are congruent. That's the angle by the vertical angles theorem. And that Q is congruent to P. Now this is a toughie. This is called the congruent supplements theorem. We know that angle Q and angle P, both of those respectively are going to be supplements to angle 1 and angle 2. Okay? So we know that angle 1 plus angle P equals 180 degrees. We know that angle 2 plus angle Q equals 180 degrees. So because we know that you're going to have to add the same amount to both values of angle 1 and angle 2 to get 180 degrees, that means that the remaining is the same. Okay, so that whatever we would be adding to it is the same. And that's what gives us P and Q is congruent. Now I could go and say that now that I have side or angle side congruency, and then go the Cpctc way. Say that because triangle PAO is congruent to triangle QOB by angle side, that angle A and angle B are congruent because their corresponding parts are congruent triangles. But there's an easier way, in my opinion, to do it. We already know that angle O, those two center angles, are vertical angles. We were just able to show that because 1 and 2 are congruent, that P and Q are congruent, and that gives us that A and B are congruent by the third angles theorem. Remember the third angles theorem? It's actually up on the board still. It says that if two angles of a triangle are congruent to two angles of another triangle, then their third angles are also congruent. And last one. So, this one I'll go through a little bit slower. So we have angle 1 is congruent to angle 2, WX is congruent to ZY. That's going to be given. So the next one is WP equals ZP. Now we know that WP equals ZP by the converse of the isosceles triangle theorem. Remember, we were given that 1 and 2 are congruent. And so if we're to look at this triangle down here, and we look at just the outside triangle, okay? This right here. We see that 1 and 2 are its base angles, okay? So the converse of the theorem says that the isosceles triangle theorem says that if two angles of a triangle are congruent, then the sides opposite are congruent, okay? So because we're already given the converse isosceles, we're given that 1 and 2 are congruent, we can say that WP and ZP are congruent. Now we're asked to say that those two small triangles on the outside are congruent. That's WXP and ZXP, or ZYP, and those are congruent by side angle side. We were given the short sides at the bottom were congruent. We were given that the angle was congruent. So then we were able to use the converse of the isosceles triangle theorem to say that the other sides are congruent. So that's going to be side, angle, side. XP has to equal YP. Those are those triangles on the inside. Because corresponding parts of congruent triangles are congruent. And just like we started off by saying that because the two angles are congruent, the two sides are congruent, that's the converse, so we want to switch that around for the actual isosceles triangle theorem, which says that if two sides are the same, then the opposite angles are the same. We were able just to use the corresponding parts of congruent triangles to prove that XP and YP were congruent, and then we were able to use those two to say that 3 and 4 were congruent. I hope this helps. Have a wonderful evening/morning, everybody. And get some sleep if you can, and be ready for the test tomorrow. Thank you for watching.